I'm going to get more into the details of Couchbase Lite itself. So I don't really need to give you the feature overview because Wayne and Ali did a great job of that in the previous talk. So I'm going to get into Couchbase Lite, talk about, it's going to be a mixture of kind of hands-on or optionally hands-on and principles, because some people like just diving in and like downloading code and looking at source code and running stuff, and some people like to hear about all the moving parts before they get in. So I'm going to try and do a mixture of both of those. I'm going to talk about the Couchbase Lite architecture and the API, sort of in the context of explaining our simplest sample app, which is called Grocery Sync. And then get into some of the next steps that you can do, both talks here at the conference and online resources that you can look at. So the Couchbase Sync Gateway, I'm really not going to be covering here. That's going to be the focus of the next talk after mine, which will be at 1:45 after lunch. But I will be talking about Couchbase Lite now. So it is an embedded database library for mobile apps, mobile or desktop, actually. It essentially comes in the form of either a static or dynamic library that you link into your application. It has a NoSQL data model. I think some mobile developers, I use the word NoSQL and they go, huh? But I think at this conference, people probably have a good idea of what that means. In particular, it's a document database, very much like Couchbase Server. The querying is done by using MapReduce in the same way that Couchbase Server supports and CouchDB also. And as Wayne already showed off previously, that we support change notifications so that you can do reactive UI development. And of course, the kind of the crown jewel of the whole thing is the multi-master replication. So the replication helps you avoid network latency when you're accessing data. It takes the network off of your critical path. It gives your application full offline support if you want offline support, if you want to go that far. Or you can have a kind of hybrid app that has some online-only features, but combined with offline access. You have full control over conflict resolution. I've seen that some sync engines will sort of sweep that feature under the rug and kind of pretend that conflicts don't happen. But conflicts do happen, and we give you full control over them. And we support arbitrary networking topologies, everything from star through peer-to-peer. That is going to be the subject of the talk that I'm giving this afternoon on peer-to-peer replication. So know more about that now. And one thing that doesn't really get said enough is that the replication is an open protocol. And I think it's unique in that the protocol was designed as part of CouchDB, and it's supported by a number of other systems now, including PouchDB on the client side, and Big Couch and Cloudant both use it on the server side. And it's fully documented. So now we're going to dive into actually building and running an app. I'm going to talk in this here about both iOS and Android, sort of alternating back and forth, which makes things a little bit choppy, and I apologize for that, but it's sort of the only way to cover both of these platforms. So this slide specifically talking about iOS, and I'm going to be putting these little icons down in the corner to make it clear like when a slide is specifically about iOS or specifically about Android. So for iOS, you would, and you actually could be doing this following along, or you can wait and do it later at your leisure. The slides are going to be available online pretty soon. I don't know exactly when. Obviously, you install Xcode, the Apple Developer IDE. You would download the Couchbase Lite framework. You download the Grocery Sync sample application source code. Then you install the framework into the sample app, since it doesn't ship along with it. And then you can build and run it in Xcode. And I'll sort of step through this. There's the URL there from which you can download Couchbase Lite. And we have the various platform versions available there for download. And the folder on the right shows basically what you get, these two frameworks, where the main one that you want is the Couchbase Lite.framework, which includes the library itself. After that, you would download the Grocery Sync source code from GitHub. The URL is there. You can use Git to check it out if you want, but if you just want to play with it, it's probably faster and easier just to click the download zip button and get the archive. I'm also going to repeat those URLs at the end of the talk during the Q&A part. So if you didn't have a chance to write it down, that's OK. Adding the framework is really easy. You just drag the Couchbase Lite framework into the frameworks folder in Grocery Sync. We didn't include it in there automatically just because we don't want to have to update Grocery Sync every time we update Couchbase Lite and bulk up the size of the repository. And then finally, you open the project. Just double-click the Xcode project, and then you can build and run it. So in Android, you would install Android Studio, and you will need the Android SDK 19 and Build Tool 19 parts. Then you would check out the sample code repo. I'm told by the Android people that you actually need to use Git to check it out. For some reason, downloading it doesn't work. You then import the Gradle file into Android Studio, and the import process will actually check out and install the Couchbase Lite framework for you, which is nice. And then you just run it. So yes, Android. So the git clone, the URL is there on the command line. It's obviously not exactly the same repo, but a very similar URL. Then you do the import in Android Studio to locate the build.gradle file that's in the repo, and then you run it. So I'll give a quick demo now of iOS. Yay, OK. So I'm not going to show you the download and copy and drag stuff, but here's like what it looks like in Xcode. And then we just click the run button, run it, and it comes up. This is the Grocery Sync app. So it's really kind of the simplest, non-trivial, actually somewhat useful Couchbase Lite application, which is why I like to show it off. We have some more advanced ones like To-Do Lite is a much better to-do list with more features, but the source code is, of course, a lot more complicated. So Grocery Sync is what I'm going to be focusing on here. And I've got it running on my phone, too, so I can go here and I can type in, like, how about bread? Add bread, it shows up there. And then on this side, I can check off bread. And as you can't see, it's checked off on my phone, too. I can check off mangoes. They check off over here. So the latency we're getting right now is like sub-second, like quarter of a second or something, which is sort of an optimal case because the server that's hosting this, the sync gateway that's hosting this, has no other load on it. It's just doing nothing but responding to me. So the actual latency back and forth is really very quick. So now we can go back to the presentation. OK, so the rest of this is going to be a tour through the source code of Grocery Sync, or I'm focusing on all the individual bits of the source code that are dealing with Couchbase Lite. So we'll start off with just initialization, like starting up Couchbase Lite when you launch the document, and then inserting new documents, where each document obviously is one of those to-do items. So here's the source code. There's not going to be a quiz on this at the end. I'm not expecting people to read and understand every line of the code. I've sort of highlighted in yellow the kind of most important bits here. So at launch time, the first thing we'll create is a CBL manager instance, which is sort of the top-level Couchbase Lite object. And then we're going to ask it for a database with a particular name. And this will have the side effect of creating that database if it didn't exist already. So we just sort of have this one call that we need to make as startup. And as part of that, we get this database object, which we then assign to self.database so we can have a handle to it later. And we've got some rudimentary error handling there. If we couldn't get the database, then something went terribly wrong. And as with all of these, I'm going to then flip over and show the Java version, which I may be a little more superficial here because I don't work on the Java version of Couchbase Lite, so I'm not as familiar with it. But as you can see, it's basically the same thing. We are instantiating a manager. The Android code has package names, of course, so it doesn't use the CBL prefix the way Objective-C does. We instantiate a manager, giving it an Android context, and then tell the manager to get the database. So as you see, in wherever practical, we're using the same API between platforms. Manager class, get database method, with variations where necessary to either tie into the OS, like passing the Android context in here is obviously an Android-only thing, or to tie in with idioms, like the way event handling and notifications are done is obviously completely different between Objective-C and Java and C#. So let's go into what these objects actually are. The manager, as I said, is the top-level object. It's usually a singleton. On iOS, the objects are intentionally single-threaded. So if you actually want to run Couchbase Lite on multiple threads in your app, you will need to create a manager on each thread to work on that thread with you. But generally, you're just using a singleton instance of it. It primarily acts as a namespace for databases. So you can ask it for a database with a particular name, and that's how you get a hold of your databases. It also locates the databases in the file system. So you can optionally create a manager and give it a directory path and tell it, this is where I want to put my databases. Although if you use the default manager instance, it'll just pick a reasonable location for you. Like in iOS, it'll go into the application support folder. So once we have a database with a name here, which is to do, we can then get documents out of it. The database is a namespace for documents primarily. And very much like Couchbase Server, it's this flat namespace, pretty much a key value store where the values are these documents containing JSON. So the documents each, of course, have this unique name, unique ID. Beyond that, they have JSON as properties. So there are a JSON object with a set of named properties whose values can be strings, numbers, arrays, dictionaries, et cetera. So here I've got sort of a simple little to-do type object with some tags on it to show that we can have properties that are arrays. One way in which we deviate a bit from Couchbase Server is that we allow attachments. Since it's not very practical or it's not very efficient to store binary data in JSON because it has to get converted to base 64 and then increases in size, the document allows you to attach an arbitrary sized binary blob, or actually any number of arbitrary sized binary blobs, which are also tagged with names and MIME types. These also help optimize replication. So if a document is updated without updating an attachment, the replicator can skip sending the attachment again. So you might have, like in an iTunes type app, for example, you might have a document that has a couple hundred bytes of metadata about the track and the artist name and so on, and then it has this 10 megabyte attachment that's the MP3 or AAC file. And so if you just update the metadata, you don't need to replicate that file over again. So database, in addition to being a namespace for documents, it also contains the views and their indexes. And I will get into views a bit later. It's almost exactly like on Couchbase Server, if you're familiar with that. They're MapReduce indexes for querying. It contains validation functions, which can be used to validate the structure of every document that gets inserted into the database. And that includes insertion locally by the application, as well as documents coming over through replication. So it gives you a chance to enforce any kind of constraints that you have on what your document schema looks like. And a database also serves as the source and the target of a replication. So when you replicate, you set up a replication object that will say, I want this local database to be replicated to this remote database, or vice versa. The document has this immutable ID within the database. It looks like an underscore ID property, which is immutable, of course. The JSON, I just thought it was worth pointing out that you can arbitrarily nest stuff in JSON. You can create arrays with objects in them, or nested objects with objects in them. So if you haven't worked with this before, it's very different from the way that you structure your data in a relational database, because you are kind of encouraged to store structured data into your documents. Like in an address book application, for example, you would probably store all of your contacts' phone numbers as an array of strings, instead of having to create a phone numbers table and create a separate instance of phone number in that table with a joined document. The documents in your database, of course, don't have to have the same structure, since that's what makes this, well, part of what makes it a NoSQL database is that it's schemaless. The convention that's used pretty commonly is to have a property called type, which has a string that defines the type of your document. So you might have like an to-do item type and address card type, and that will help you keep track of which documents are which, especially when you're indexing them, so you could index them into separate indexes. Documents are versioned. We have what's called multi-version concurrency control, and I could do a whole talk just about that, so I really don't have time to get into it in here. The key takeaways are that, this is key to the way that replication works and the way that conflict handling works. That when you have a conflict, it simply becomes a branch in the history of the document. And it's a valid state for the document to be in, and the replicator will transfer that state back and forth. It just means that now you have multiple possible current versions of it that you will then probably reconcile together into one and kind of prune that tree back into a linear branch. But the document tree is what allows you to do that. MVCC also takes care of handling race conditions where two processes in your app try to update a document at the same time, or your app process and the replicator try to update the document at the same time. Like you read the document, modify it, put it back, but before you had a chance to put it back, the replicator updated it. The MVCC will catch that and actually return an error back to you saying, hey, there's a conflict. And you get a chance to reread the document and update it before it even gets stored. So it's sort of ahead of time conflict handling for the very common case where you're making changes locally. So let's look at inserting documents into the database. So the second yellow sticky here, we're creating a new document, and the create document method will just return a document whose ID is a randomly generated UUID. You can define the IDs that you give your documents, and that's sometimes a very useful thing to do, but in a lot of cases, you just don't care. I want a new document, and I don't want it to collide with any document anybody else has created. Then the top part here, we're creating an NS dictionary, which is, that corresponds to a JSON object in Objective-C, with the text, the property for the check mark, which starts out no, and the created at is the creation date. And since you can't store dates as native objects in JSON, we're using a utility function called JSON object with date that will take a Cocoa date object and convert it into a string in the ISO 8601 format, which is fairly universally used in JSON. You might wonder why there's a created at field since it doesn't show up in the UI. We're not displaying the dates that which these items were created. The date is used for sorting so that we can display the most recent items at the top and the older ones at the bottom. So if I had time to really dive into the indexing, well, I'll show a bit of it later. Again, we'll translate this into Java. There's a bit more code here because they're doing more of the work directly to construct the date time string. So the first block at the top really is just creating this, this current time string for the object, and then also they're creating their own document ID by sticking the current time onto a UUID. The rest of it is pretty much the equivalent in Java. They call database.createDocument. They create a map, which is the Java equivalent of a JSON object. Can you save questions till the end? Yeah. And then putting the same properties into that Java map and then calling put properties. So next I'll get into views and queries. So start out with the source code, even though it may not make a lot of sense, and then immediately get into the theory behind it. So first we're creating a view in the database, and as I said, the database is also a container or namespace for the views. So we say view named by date, and if the view doesn't exist already, it will create it. If it does, it returns it. And the rest of this call is to set its map block. So this is a MapReduce view, and so that means it has a map function. And that big yellow highlighted block is the map function itself. So I'll come back to this slide in a moment, but first I'll go into a bit of the theory behind this. So MapReduce sort of initially comes out of functional programming, which actually has fundamental functions called map and reduce. It was adapted into a means of highly scalable indexing and querying by Google. And I found we could talk about the functional stuff. People can kind of wave their hands about what it does, but really it's so much easier if you can just see it in some kind of formal logic fashion like that. So that line there, I think, should just make everything crystal clear. Or if not, then what it's saying is that you start out with a document, a JSON document, and the map function is just a function that you write that takes that document as input, and it outputs a set of key value pairs. So you're sort of extracting the useful information out of this document that you want to index and providing it. Here's a key, here's a value. You could emit none if the document isn't relevant to your index. You could emit multiple key value pairs if there's several things in it. So the output of that map function, as run over every document in the database, generates an index. And just like an index in a relational database, it's just sorted by key. And you can optionally use a reduce function, which can aggregate those rows together. So it can take rows with the same keys, or actually all rows in the index, and run a function that you define that will sort of coalesce everything together. You'd use that for things like averaging or counting or computing statistical functions. It's not as commonly used as map, but it definitely comes in handy. So then once you have this index, you query it. The querying is mostly done by saying either I want all of the index entries with a particular key, or a set of keys, or a range of keys. So here's sort of a visual idea of it. So on the left, we've got sort of this train of documents going by. You can think of this as being chronological. So every time a new document gets created or updated, it'll pop into that conveyor belt there. And the map function is running along these. So every time something changes, the map function gets fed that document. In this case, so the map function calls a function called emit, which takes the key and the value as parameters. So the map function here decides that it wants to emit doc.created as the key and doc.title as the value. So on the right, you can see this index being generated that has these key strings, which are the timestamps, and value strings, which are the names of the to-do items. So this is pretty much what the what the grocery sync application is doing. It's generating this index of all the to-do items sorted by key. And since the key is the timestamp, we get them chronologically ordered. Also in that third column on the right, the index also remembers the document ID of the document that emitted that key value pair. So when you're querying, when you have a row in your query, you can use that to go back to the document and fetch the entire document out of the database if you want to. So if the key and the value themselves aren't enough, you can get everything out of it. So back to the code now. So hopefully this will make a little bit more sense. This is similar to what I showed. It's just that it's in Objective-C instead of in the sort of JavaScript-like pseudocode. So first we get the date out of the document by looking at the created@at property. And if the document has one, then we emit that as the key. In Grocery Sync itself, it's not emitting anything for the value because it's actually going to go back and grab the document itself to get the rest of the data from. And there's a version string at the end there, which is used to tell the database if your map function changes. Since it doesn't have access to the source code, it can't really tell whether it's changed from one run to the next. So instead, you bump that version string, and that tells the database that it needs to throw away the index and rebuild it. This is the Java version. Again, very similar. So we call database.getView. And then we're creating the map function, which in Java exists as a mapper object. And so we use some inner class syntax here to create a map function for it, which does exactly the same thing. So once we've got this stuff in the index, now we want to use that index to drive this table view, which is the main part of the Grocery Sync UI. In iOS, what we do is we generate a query. So we say, view named by date, get the view again, call query, which creates a query on it. And then we say as live query, where, as I'll get into on the next slide, live query is a special subtype of query that will actually track the view over time. We set the descending property to yes, because we want to get the rows in descending order of date, so we can have the newest ones up at the top. And then this is some very iOS-specific code where we've got our data source, which is the thing that's driving the table, and we're telling it about the query, and we're telling it which property we want it to actually show as the label in the table view. The Android version starts out the same way. It creates a query and then calls to live query on it to generate the live query. It calls add change listener on that live query. It's doing a little bit more of the work directly here since it doesn't have exactly the same platform-specific class to do the work. So this code below there is going to get called, this changed method is going to get called whenever the query updates. That is, whenever the results of that query change. And it's going through an iterator to get all the rows out of the query and add them to this Grocery Sync array adapter that it has, which is a custom class it has for storing the data set. So here's querying in a more graphical form. We've got that index that we built a couple of slides ago. And the query is going to look at a range or a subset of the keys in there. Queries have a number of properties that we can set. So in this case, we've set the limit to 3, which means we only want to get 3 rows back. You can set an offset, which specifies how many rows down to start. You can reverse it if you want. And very often, you'll set a start key and an end key to get just a particular range of keys out of it. You might want to get like all of the elements from last month, say, something like that. And the output from when you run the query is going to be an array of query rows, where each query row is an object that has properties like key and value and document ID, and also a document property, which will load the document back out of the database for you. So live query, as I said, is a sort of wrapper around a query which listens to change notifications from the database. So when the database changes, the live query will kick off the query again and rerun it in the background asynchronously, and then compare the results with the previous results that it already had. And if the results have changed, the live query will signal its own notification event, which your app can then use to probably redraw the UI based on that query. So in iOS, there's a platform-specific utility class called, well, I'll get into it. So we have the live query, we have the UI table view over here, and we want to connect them together. And we have the application controller code. So what we do is in the middle of it, we put this iOS-specific Couchbase Lite class called CBL UI table source, which acts as this intermediary that will drive the table based on a query. So you point this thing at the live query, and it will receive the change notifications from it. And it also acts as the data source object for the table view, which means that it's the object the table view is going to ask to provide all of the data for the rows. And then your controller object becomes the delegate of the table view, and that means that it will get notifications from the table view about things like when the user taps on one of the rows, or it also gets to configure the appearance of the rows in the table. So you can actually see this in a very graphical way in the interface builder view in Xcode. So the file's owner up there on the top left is the application's controller, its view controller. The table source is a custom object on the left as well, and then the table view, of course, is the mock-up of the table view in the main window. And the outlets on the right are actually showing those connections that I've drawn there in the blue chalk. So back into the iOS code, and I will show more Android code after this. This is a callback that the CBL UI table source invokes on your controller object, telling it that it's got a query row, and it's got a UI table view cell, which is the UI representation of the row. And it wants you to populate that cell. So the method here gets the value out of the query row, which in the case of grocery sync, I believe it is pretty much storing all of the properties of the document there. So it would be the check mark and the text. So it's getting that check property as a Boolean and setting up the color and the check mark image based on whether it's checked off or not. CBL UI table source has this handy ability, like back several slides ago, we told it which property of the document to use as the text for the row, so we don't actually have to set the label in the cell ourselves. It's done that for us. Here's the Android equivalent in the grocery sync array adapter class, where pretty close to that. It's getting the query row by calling getItem based on the row number in the table. It then gets the document from the query row and then gets its current revision, and then uses the check and text properties to populate the UI controls in the row. So next, and I think this is close to being the final thing, is actually responding to a tap on the row in the table to toggle the check mark. So we're back in iOS. This is a method that's called by the UI table view itself on its delegate telling it that a row got selected, which means tapped. So it's going to go to the data source, which is the UI table source object, ask it for the row, the query row at that index, and then get the document out of it. So now it's going to do basically you read, modify, write cycle on that document where it gets the properties, makes a mutable copy of the properties, so we now have a mutable dictionary that we can update, reads the checked property out as a Boolean, and writes it back in as the opposite. So it's inverting the Boolean value of the checked property. And then it calls put properties at the end to save that value back in. And this is one of the ways in which it being just a simple demo app shows off that it's possible to have a race condition here. If in the time window from here to here something else modified the document, probably the replicator, this would return an error. You'd get a conflict error. In a more fully featured app, you'd actually use a slightly more complex version of the put properties that will sort of automatically handle that and retry the update. But Grocery Sync doesn't do that. Android version again, so we have an on-item click that gets called by the Android GUI. It's going to get the query row at that position, get the document, get the properties out, exactly the same thing here, just in Java syntax instead of Objective-C, and then put the properties. And the put properties, since in the Java API, it's idiomatic to use exceptions where it's not in Objective-C. So this has a try-catch wrapped around it to handle an error saving the document. OK, change notifications. Wayne went into this a bit. We have 3 types. There's the database change notification, which gets triggered anytime any document changes in the database. If you have a reference to a document that is a document object, you can listen to change notifications from that document specifically. And live queries will post notifications when the result set changes. In iOS, the first 2 of those are NS notifications, and the live query change is actually done by key value observing. So you would actually observe the rows property of the live query object to get notifications. And I can't tell you how that's done in Java because I'm not familiar enough with the APIs there. So this turns out to be really nice, and it enables what's currently a trendy buzzword in GUI circles of reactive programming, which basically means that you've got your model view and controller, although it might be a view controller or a view model or any of the currently popular variants thereof. And so obviously the view is going to be sending user events to the controller. The controller is going to turn around and update the model, which in our case is the database. Now the controller then doesn't have to go back and update the view corresponding to what changed. Instead, the model is going to send it notifications back, telling it what changed. And then the controller can respond to those notifications and redraw. So you'll notice back on the slide where we toggled the check mark, it didn't have anything in there to redraw that row in the table. You don't need to, because as soon as you save the document, that's going to trigger a database change, which triggers the live query to rerun the query, which will then tell the application that that row changed, and it'll redraw it. What's great about this is that there are other things that can cause the model to change other than this particular control path. So there might be other controllers that operate on the same documents in the model. Or actually, very likely, you have a replication. If you have a pull replication, it can be bringing in updates to documents or new documents from the server at any time, asynchronously. And so if you're programmed your stuff this way, then those replications will trigger the same change notifications, and your UI will automatically update correspondingly. OK. Finally, and then this is the last bit here, we'll go into the actual replication stuff. So replications are represented by objects whose class is replication. And a replication can be in one direction or the other. So it can go either push, which will send documents to the server, or pull, which will bring in documents from the server. Replication runs asynchronously. So you create a replication object, you configure it, and then you start it. And then from there on, it's just running in the background. And you communicate with it by notifications, or it communicates with you by notifications. So you'll see database notifications as it's updating documents. You can also listen for notifications directly on the replication to get progress information or errors. The replications can run as either one-shot or continuous. So the default mode is the replication will start up, connect to the server, find all the stuff that needs to be transferred, transfer it, and then stop. The continuous replication will keep going even after it's caught up and basically monitor either side. So if it's a push replication, it's monitoring the local database. If it's a pull replication, it's monitoring the server. And if there are changes, it will wake up again and copy those changes across the network. It also handles online and offline gracefully. So if your device goes offline, the replication will pause. As soon as you come back online, it will detect the network change, wake up, and try to continue from where it left off. I don't know if you've ever tried to implement this on your own, but it's fairly tricky to do and to get all the little moving parts right, especially if you get interrupted halfway through and have to restart. So that's a big part of the complexity, and I think the value of Couchbase Lite is that it handles this kind of stuff for you. A final detail about replications is that they can be filtered, so they don't have to transfer all of the available documents. They can transfer subsets of them. On a push replication, you can write a function that you apply to the database called a filter function, which is just a predicate, basically, that looks at a document and says yes or no. So it can arbitrarily decide which documents it wants to replicate and which it doesn't. On the pull side, it's done on the sync gateway through the use of channels, which is a kind of involved topic that's going to be covered in the next talk after this. But so on the server side, it's useful because the server database may be enormous, and you don't want to pull the whole thing into a client, and it probably contains data that's not relevant to that client or that the client doesn't have access to see. So the filtering there will help it make sure that only the necessary documents go down to the client. OK, so to create a replication, we just call create pull replication or create push replication. Here we're creating one of each, which is a really typical pattern because we want bidirectional sync. We set the continuous property of each one to yes because we want grocery sync to keep syncing as long as the app is running. And then we are adding some observers. So this is Cocoa code to capture those replication change notifications to update the status. And then finally, we tell it to start. The Android code is really almost exactly equivalent. It's just that it's in Java instead of in Objective-C. So we create pull replication, set continuous, start. And we just call an add change listener to pass the receiver in to get the notifications. Monitoring, this is a lot of code, but the interesting part is just that this is a Cocoa notification handler that will get called by the replication. And the bits we're pulling out, we can ask for the pull replication or the push replication status. So this is checking to see if either one of them is currently active. If they're active, then we look at these properties, changes count and completed changes count, where completed changes count is how many documents it's already either pulled over or decided that it didn't need to, and changes count is the total number. So this dividing the two gives you a fraction of current progress. It turns out this isn't a terribly useful measure because the number of documents that need to be synced isn't really known ahead of time. It's sort of being worked out on the fly at the same time that they're being synced. So there's kind of one socket that's pulling in the list of documents to sync, and the other one is pulling the documents themselves. So kind of more stuff keeps arriving. But it's better than nothing. It does give the user a sort of progress bar to watch while things are syncing. The Java code is very similar. This is the change method that gets invoked by the event, checks to see whether the replication is running or not, gets the completed changes count and the changes count. And I guess this one is just logging them to the console instead of driving a progress bar. But it's pretty straightforward to hook that up to a progress bar as well. And at the end, there's also looking to see if the notification has an error, and if it is, showing that error to the user. OK, that's it for that. I'll go over some of the next steps, and then we have some time for a Q&A. The talk after this at 1:45, so I guess that's, well, maybe 1 or 2 sessions from now, but the next mobile talk is going to be covering Sync Gateway. That's 1:02. I haven't seen the talk, but I think it's pretty much equivalent to this, just in Sync Gateway terms. Going to be diving into the actual architecture and how you would configure the Sync Gateway and set up your own applications on it. I am giving a talk at 3:45 with my colleague Pasin on peer-to-peer sync, which seems to be a popular topic, judging from the questions on the previous presentation. We'll talk a bit about what it is and how to do it, and both Pasin and I have applications to demo that show off some of the techniques. And then at 5:15 today, there's going to be a session on using Couchbase Lite with Unity. This is using the .NET C# version of Couchbase Lite for mobile game programming. There's a bunch of other stuff you can do. After you've been to the next talk, you should be able to download Sync Gateway and start up your own local copy of it to connect your Grocery Sync app to, so you can sort of play with local synchronization. And yeah, I did put the URLs here since you can't click on the links. We have a bunch of documentation online. We have a bunch of other sample apps online. To do Lite is sort of the next one up. It's similar to Grocery Sync, but it has a lot of features like multiple to-do lists. It supports multiple users, so you can share to-do lists with other people. You can keep your own to-do lists private from other people's. And as Wayne said before, the Couchbase Connect conference application was actually built using Couchbase Mobile by people at Firefly. And the source code to that is available as open source. We have developer forums online where you can ask questions about Couchbase Mobile. That's the URL for that. Or, of course, you can ask about non-mobile stuff in the other forums on that server as well. That's the end. And I'm going to leave the URLs up. So those are the ones from the beginning about how to download Couchbase Lite and the Grocery Sync app, if you wanted to scribble those down. But I think, actually, this might be exactly the end. Are we at the end of time, or do we have time for questions? OK, maybe a couple of questions. Yeah? Questions about Swift. Yeah. Objective-C and Swift obviously bridge together really easily. And if you go to the GitHub repo for Grocery Sync, the iOS version, the main branch is Objective-C, but if you can check out a branch called Swift, which is exactly the same thing but translated into Swift. Question is, what's the difference between the community and enterprise editions? There isn't one. Couchbase Server, there are some differences. There are some features having to do with very high scalability that are only in the enterprise version. So I guess to leave room for future growth, we sort of have all of our products divided up into community and enterprise. But at the moment, they're built from literally exactly the same source code. So it doesn't matter which one you use. One more?
Your presentation, you mentioned about _ID, the unique key, and it's immutable. But if you create a document in distributed manner, it is impossible to assure that. How do you manage that?
Yeah, so if you want a document not to collide with something else, then you give it a UUID as a key, where universally unique ID. So it's got, I think they have like either 128 or 160 bits of entropy in them. So it's essentially impossible for two people to create the same one at the same time. There are cases though where you do want, if you want to ensure that there can only be one of a particular document, like this is the user profile for Jens, then you might actually want the document to be named Jens to ensure that there can never be two different profiles for the same user. But essentially, the default create document method, the one that doesn't take any parameters for the ID, will use a UUID to give you a random ID. OK, that's it. So I'm going to hang around a little while if people want to just ask questions informally. And thanks a lot for coming. And make sure you go to the other sessions, too.